In this video, I'm going to go through some problems on the worksheet, solving trigonometric equations by graphing. I like to do this in the graphing unit, just a couple problems that kind of have you associate what it means to solve an equation, and to really be thinking about the graph when you do it. In the next unit, we solve equations without actually resorting to graphing, okay? All right, so let me go ahead and work through a couple of these so you can think about it. All right, so this problem wants us to use a graph in the unit circle to try to solve the equation for negative 2 pi is less than or equal to x is less than or equal to 2 pi. So we're going to look and see for which x values between negative 2 pi and 2 pi does cosecant of x wind up equaling 1, okay? All right, we're supposed to use a graph to do that. So that means we want to try to get a graph drawn. So I'm going to think about that. And I'm going to remember that cosecant is related to the sine function. So what I'm going to do first is graph y equals sine x. Okay, so I'm going to think about getting the graph of that done in the usual period and all. So the sine goes from 0 to 2 pi. So let me get 2 pi on here. Cut that in half. Okay, let me also get negative 2 pi on here since we got to solve from negative 2 pi. So I'm trying to make it, there we go. And then sine, the beginning point is 0 and the ending point is 2 pi. And so we'll also want these halfway points. So that's pi over 2 and 3 pi over 2. Okay, so we know what sine does because we can think about the unit circle. I'll do it right here in those key values. Okay, and so then we wind up thinking about what sine does on those 5 key points from 0 to 2 pi. Okay. We know that the sine of those, we know it starts at 0, goes to 1, goes back to 0, goes to negative 1, goes back to 0. Okay, and so let me put the 1 on here, negative 1 on here. So it goes like this, starts here, goes up, okay, and then back. So it looks like this, okay, and then in reality, it keeps going, doesn't it? The same pattern, you know, we could extend it, same pattern here. So it goes down, back to 0, up to 1, there. All right, and I really wanted to make sure I saw it between the negative 2 pi and 2 pi because for these problems, that's what it's asking us to do, is to find out where the cosecant graph, find out where cosecant of x would equal 1. So here's the way to think about this. So that's sine, okay? And then remember how we do cosecant. Everywhere you have an intercept, you're going to have an asymptote because cosecant is 1 over sine and 1 over 0 is undefined. So these are going to be your asymptotes, okay? And we keep going like that. And then your cosecant graph is going to be on every one of those high points, you're going to have that U shape. Okay, something doing that, okay? So there's cosecant. All right, now what I want you to think about is how to see what the solutions are. We want to know where does cosecant, for which values does cosecant of those values turn out to be 1? And I know they're really just real numbers, but it helps just to think of that x right there as an angle. So it's like for which angles is the cosecant going to turn out to be 1? And you can look at the graph to get that. Let me change it to a blue color. So see this 1 right here? Okay, that's like where does the output of the function turn out to be 1? Where do the y values turn out to be 1? So here would be where y's are 1. And you see how that happens for all of those high points? And then you only need to report between negative 2 pi and 2 pi. So that means you need this one and this one. Okay, so for that first problem, the answer to this question should be when x equals, this would be negative 3 pi over 2. Okay, that would would be negative pi over 2. Okay, so it would be at negative 3 pi over 2. And then over there at pi over 2. So just at those two spots. Okay. All right, now let's think about tangent. We have the tangent of some angle being square root of 3 over 3. Now I said use a unit circle, but gosh, when I saw the square root of 3 over 3, I was thinking about a 30, 60, 90 triangle because that's when that square root of 3 gets involved. So you may want to throw that in the mix so you can think about it a little bit. Or you can go to the unit circle if you're more comfortable. I'm looking at the unit circle right now and looking for like square root of 3 over 3, where that might come from. And remember here we're dealing with tangent. So tangent is the y coordinate over the x. You know, it's the sine value over the cosine value. So it's the y coordinate of the point on the unit circle over the x. So you got to see, well, where would that wind up being square root of 3 over 3? So it turns out when you look at it, do you see on the unit circle, when you're right over here, how the ordered pair for the pi over 6 is square root of 3 over 2 and 1/2? And so it might come from there. So you try it. So the tangent would be the y coordinate over the x coordinate. And you see when you simplify that, if I multiplied top and bottom by 2, I'd get to here. And then if I rationalize that, it would be square root of 3 over 3. Okay, so that's one spot where it happens. I can tell on the unit circle that that's one spot where it happens. And that is pi over 6. And notice when they ask it this way, they're asking for it in radians, okay? And they don't intend for you to just inverse tangent. They're asking you to do this by thinking about the graph in the unit circle, okay? So if I'm thinking about tangent, okay, what I'm thinking about with tangent is that it does this. There's asymptotes. Let me do them in red. I remember those asymptotes at 0 and at pi because it's undefined there. Then it hits 0 right here, and then it has kind of a positive slope. Okay, so that's not really mathematical, but that's the way I think about it. It's increasing. Okay, so it does something like that. In the halfway points, it hits at 1 and -1. And then that just gets repeated, doesn't it? So when you're over here at 2 pi, or when you're over here at negative pi, or over here at negative 2 pi, you're going to have that same thing happening over and over again. So that means you'll have another one of these in here, another one in here, and another one over here. And see, that's 2 pi, that's negative 2 pi, okay? So we got to think about that square root of 3 over 3. And if you think about that just as a number, the square root of 3 over 3 is going to be the decimal, like 0.57, 0.6 or so. It's about 0.6. So it's a positive number, not quite at 1. Let me do this in green, just a completely different color. So it's like I'm looking for all the spots where the output to the function turns out being 0.6 about. Okay, so this is my x right here. The blue is my x and my y. And then that right there would be where y would equal about 0.6. And so between negative 2 pi and 2 pi, I should have 4 answers. Here they are. Okay, there should be 4 answers to that question. I know one of them is pi over 6. Okay, that's this guy right here. That's pi over 6. So it's going to happen again in a similar location on this one. And then it's going to happen again on that one and again on that one. Okay, so I just need to see then where are these other spots. So if you think about this being 0 to 2 pi, that's this way. That one would have the tangent being a positive square root of 3 over 3. Okay. And then here's a reference angle that would have the same situation, same type of thing, but it would be negative square root of 3 over 2 and a 1/2. So if you did the y over the x there, it would be a negative. So that's not true. But then wouldn't it happen here? Okay. And so you have to think about that. That would be over there at 7 pi over 6. So at pi over 6 and at 7 pi over 6. Because see how that's negative square root of 3 over 2 and a negative 1/2? So if you did your y over your x on that, it would turn out to be a positive, and it would turn out to be like before. And once you rationalize it, you'll get square root of 3 over 3. So from 0 to 2 pi, I've got pi over 6, and I've got 7 pi over 6. Okay. All right, now, another way you can find these is once you find 1, you know how the period of the tangent function is pi? Notice that going from here to here is adding 1 pi. It's adding pi. It's adding 6 pi over 6, and that got me there. So what I could do, instead of trying to figure it out from the unit circle, is I could just go this way and subtract pi. So I need this guy and this guy. So I could subtract 1 pi, and then I could subtract another pi. So that's another way you can do it, okay? All right, or the other thing would be for you to think about what's this angle called, because that's where it happens. You just need to think about what that angle's called. So you see, if you go that way, if you went all the way to here, it would be negative 6 pi over 6. So this would be negative 5 pi over 6. Okay, and then if I kept wrapping in the negative direction to here, that's almost all the way around. So it's almost around to 12 pi over 6, but I got to back up 1. So it'll be negative 11 pi over 6. All right. So let me clean this up a little bit and make sure you see that idea. You can use the period to help you find where the next one's going to be. So once we got an idea that we had 2 places where we were going to get the tangent to be square root of 3 over 3, it was going to be here and then here. And that was the 2 places within 0 and 2 pi. Then all I did was reverse the direction and say, okay, well, let me figure out what this angle's called when I go in the negative direction, and then let me go all the way around to there. Okay, but what I could have done is taken pi over 6, and since the period of the tangent graph is pi, I can add pi to it, and that's going to give me 7 pi over 6. But I can't add another pi. See, if I tried to add another pi to that, I'd be I'd be too far gone. I'd be further than I need to be. I'd be past 2 pi. Okay, so then I could take the pi over 6 and I could subtract pi. That'd be pi over 6 minus 6 pi over 6. See where the negative 5 pi over 6 comes from? And then I could start with my pi over 6, or start with where I was there and subtract 2 pi from pi over 6, or subtract another pi from there, and see pi over 6 minus 12 pi over 6 is negative 11 pi over 6. So that's another way to confirm these, okay? All right, let me go back to the worksheet and do another snip. Let's look at 3 and 4. Okay, number 3 really looks harder than it is. Okay. All right, so one of the things I want to do on number 3 is make it look more like number 1 and 2. So I want to just try to combine some like terms and all. So what I'm going to do first is, well, first let me write it a little bigger so you can see it. Okay. All right, so what I'm going to do is subtract 5 cosine x from both sides. Okay, that'll give me 2 cosine x plus the 8 square root of 2 equals 7 square root of 2. All right, now let me move the 8 square root of 2 out of the way. And I'm going to get 2 cosine x equals negative 1 square root of 2. And you see, I want to get cosine x so it's isolated. So I'm going to divide by 2. And so that problem really turns into cosine x equals negative square root of 2 over 2. Okay. All right, so I'm trying to think about where from 0 to 2 pi and from 0 to negative 2 pi, all the way from negative 2 pi to 2 pi, where does the cosine function wind up being negative square root of 2 over 2? So you remember what cosine looks like. So the typical cosine graph starts at 1. So this is 1, this is negative 1. Starts at 1 and then goes to 0, goes down to negative 1, back to 0, and then back to 1. So it does something like that. And then it continues this way. Okay. All right, so there's cosine. All right, so what it's asking me is where does the value of the cosine turn out to be a negative square root of 2 over 2? So, negative square root of 2 over 2, that's like negative 0.7, negative 0.7. So that's going to be down here. Okay, and you see how it's going to hit within that region from negative 2 pi to 2 pi, it's going to hit the cosine graph 4 times. So I'm going to have 4 answers to this question. Okay, now I can go to the unit circle to help me find them. Okay, so what I'm going to do is look at the unit circle, and I'm going to look for cosine, and I need the cosine to be negative square root of 2 over 2. So that's the x coordinate being negative square root of 2 over 2. And you see how that happens at 3 pi over 4? And that looks about right. So this spot right here would be 3 pi over 4. Okay. And then it happens again, right? So keep going around that circle. Don't you see a negative square root of 2 over 2 when you're at 5 pi over 4? Okay. That's supposed to be a 4 on the bottom. Make that look better. Okay. All right. So I found those by looking at the unit circle. This was 5 pi over 4. And 3 pi over 4. All right, now, if you think about those angles, so let me remind you where they are, okay? So we found out when I was over here and when I was here, okay? So this was the 3 pi over 4, and this was the 5 pi over 4, okay? I had a negative square root of 2 over 2 on the unit circle. So now what I'm going to do is I'm going to go in the negative direction. So I'm going to go to here. So it's the same spot, but I want to report that angle going in the negative direction. So wouldn't that be negative 1 pi over 4, negative 2 pi over 4, and this would be negative 3 pi over 4. So that would be negative 3 pi over 4. And then I want to go from here in the negative rotation all the way to there. So that would be 1, 2, 3, 4 pi over 4. This would be negative 5 pi over 4. You can kind of tell there's that symmetry. See how those look like they're at the same spot, and so are those. So that's your negative 3 pi over 4, and that's negative 5 pi over 4. And those are the x's that are going to wind up giving you the value of cosine to be negative square root of 2 over 2. And that's what we were really trying to solve once we combined all our like terms on this messy problem. Okay, and then here's one more very similar to that one. We have 2 cosine x minus 1 equals 0. Okay, so I'm going to add 1. 2 cosine x equaling 1. Divide by 2 to get the cosine, get your trig function isolated. So now I'm looking for where is the cosine going to turn out to be a positive 1/2. Now we already took great pains to graph cosine right above. Okay, so let me erase these right here so they're not messing things up. Let me use a green color, but that same graph can be used on this one. But I'm looking for where am I going to have a cosine value equal to 1/2? Not all the way at 1, but at 1/2. It's going to happen at 4 spots, I can tell. And so I can find these by looking at the unit circle. Okay, I can find where those x's are that cause that to happen by looking at the unit circle. So I'm looking for where cosine is 1/2. Okay, so I'm looking at the unit circle right now. You should do the same. And when I look at the unit circle, I can see when I'm up here at pi over 3, the coordinates of that are 1/2 and then square root of 3 over 2. And I'm looking for where is cosine 1/2. So there's one spot. I know pi over 3 is one of the answers. Okay. All right. So when you think about it, this one right here has a -1/2, so that's not going to work. This is another angle that has the same reference angle, 60 degrees or pi over 3. And you see how both of those are negative? So that's negative 1/2 and then negative square root of 3 over 2. So still a problem. That's not going to work. But then here's a fourth angle that still has a reference angle of pi over 3. And it's 1/2 negative square root of 3 over 2. So it is a 1/2 on the x coordinate. And you can see it on the unit circle. That's going to be 5 pi over 3. So that would be one of the answers. Okay. And then to go and find what it is from all the way back to -2 pi, you just go in the reverse direction. Okay. So let's think about that. So these are the two answers that I got. But now I want to report those this way, okay? So see, that would be negative pi over 3. And then if I went all the way around to here, we'd have to try to count that out, okay? So that would be 1 pi over 3, 2 pi over 3, 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. Now, things are not always just going to be the positive and negative. You're not always going to have a positive and negative like that. We just do here. Okay. All right. And that is the way you can think about solving a trig function by using a combination of what the graph would look like and then the unit circle, and even a right triangle can help if you like to think that way. Okay. So there's 2 questions in the 5-6 homework that deal with solving an equation by graphing. They're at the end of the 5-6 homework. So you're probably ready to go ahead and do that now.